Welcome back to the Admiral Model 19A15 restoration project. In the first installment, you saw it on its arrival. We explored it inside and out and tried a power-up that was not very successful. We also discovered something unexpected, which is that the high voltage coil had been replaced with one that looks quite a bit different, and the driving circuit had been modified. So in spite of it being recapped, it's producing less than half the high voltage it should be. And I decided, rather than trying to tinker with a circuit that may never work, I'm going to replace it. And I'm going to try using one that was scavenged out of a Motorola set. I studied both circuits, and they are essentially identical, even though this looks slightly different than the Admiral. The Admiral has the same number of coils and looks similar, but the coils are a little bit larger in diameter. But even so, I'm fairly confident this will work. Kind of all these early electrostatic sets use very similar high voltage generating circuitry. So when we tried powering up, we got nothing on the screen. And then I was thinking, okay, well, how should I go about troubleshooting it? It's been somewhat recapped. Clearly someone's worked on it. They spent some money. They used some nice high quality, high voltage caps. So there's a number of places I could start. I did do some basic checks. We do have B+ in the proper range. There's no illumination on the screen. And when you're working on a TV, a really great troubleshooting aid is the image that appears on the picture tube itself. So I really want to get the high voltage going, so then we can see, do we have reception? How bright is the picture? Do we have good contrast? Are the sync circuits working? And so on. Just like sound is a great aid when restoring a radio, an image of any sort on the screen is a great help when restoring a TV. Alright, so that's what we're going to do first, is put this high voltage coil in there. Also, as another aid, I pulled out this chassis, which I got some time ago in a swap along with that chassis, which is the one I've been scavenging parts from. Part of the same deal, I got this one, which has been restored but also does not work. It gets sound reception, but also has weak high voltage and no reception, no video image on the CRT. But there is a faint raster at least. But this is a good reference because they're identical chassis revisions. So I can now see, I thought this control might have been replaced. No, it's the original because it matches that one. And so on. So if I ever get stuck about something not looking quite right here, doesn't match the schematic, I'm going to keep this one out to refer to it. So that is the plan of attack. We're going to remove the high voltage modifications, put this coil in place, wire it up, try powering it up again, and see if we can get more high voltage. Also, I did not show it, but I did test the picture tube, both that's in the chassis and the extra one that came with it. They both test fairly good. More on that later. I did record some footage. It's not so great, but basically they should both produce a watchable image. I just finished removing that high voltage coil so we can get a closer look at it. One thing I noticed right away was the winding for the high voltage rectifier tube filament seems like kind of an afterthought. It was just loosely wrapped around the ceramic core, not securely mounted or anything. Which makes me wonder, was it originally part of this, or did somebody just wrap it around? The only info I got to go on this is that it appears to say TV-230 on the ceramic core there. Some of you had suggested this might be from some type of ham radio, like a plate choke or something like that. Maybe. So we got the primary here, and 5 stacked secondary windings for the high voltage, and then that one at the top is actually the feedback secondary, or at least that's the way they're using it, or we're using it. And here's the replacement, and on this one, this is the winding to power the rectifier tube filament. So it's got 2 turns around it. Now on this, the primary is on the bottom, and then 2 stack sections for the high voltage secondary, and the feedback is this, which wraps around the high voltage rectifier tube. So fairly different design. So I'll Google TV-230 HV coil or whatever and see if I come up with anything. Another interesting tidbit is that the one cap that's mounted on it is Motorola branded. But all this wiring, these components, this may have all been added by somebody else. I mean, the soldering jobs on these tabs looks a little crude. I don't think it's factory. So, sure looks to me like somebody was experimenting with this. Whereas this is totally stock out of a Motorola TV. And I'm lucky that even that mica cap, I think the Admiral design, let's see, uses a 1300 picofarad and we got a 1250 in there. But that should be close enough, I would think. Let's see. Yeah, 1300. And the Motorola's typically use a 25L6 rather than a 6V6. But the circuit layout is virtually identical. So it'll be interesting to see. So I believe it will mount just fine. Maybe I can even reuse the screw if the ceramic shaft is threaded the same. Oh no, this one's a little bit different. Okay. So this has a threaded shaft running through it, and you can put a nut on either end, whereas this is internally threaded, so you put a screw into it. Well, I'll have to tinker around with mounting it. A little bit tricky to work under there, as you would imagine. So that hole is for the 2 filament wires to the high voltage rectifier. That is for mounting the ceramic core, and those are for all the other wires that run over to the 6V6 over here. I can't remove this terminal strip, it's riveted, so I will have to work under there as best I can. Now I do plan on replacing all these resistors, so maybe this would be a good time to do that and just clip all these out. Yeah, that's what I'll do. And then this is a 6V6 where they had done a lot of work. I'm just going to remove everything, clean up all these terminals. There's still an old original wax cap under here, which might be causing a problem too, or might have been, so that's going to go. That's a choke on the supply to this, so you don't get RF feeding back into the rest of the set. And then move on to the rest of it. So we have a hodgepodge of, there's some original paper caps, like this one buried down here. We've got some newer caps. I don't know if that's paper or plastic, but for the most part there are a lot of pretty old caps. So it's weird, I suspect there have been multiple stages. So this is a replacement cap, but this is a pretty old one. These are the newest parts in here. These are like from the 80s or 90s, I would guesstimate. But I can't imagine somebody in the 80s or 90s using replacement caps like these that would have been several decades old by then. I opened up this area as best I could by removing all those resistors from the high voltage bleeder. And the one new high voltage cap, and the components that had been tacked in. Got the socket down to where it was just the B+ and filament supply. Cleaned off the lugs, and then mounted the coil on, and it fits perfectly. When I put the high voltage shield back in place, the threaded shaft goes right through that hole. It's the right length, and I can put a nut on top, and it's going to work, I think, just fine. The original wires, these two go to the high voltage rectifier tube filament. And here are the other three. One of them is just a little too short, so I'll have to put an extension on that or replace the whole wire up into the coil. But otherwise, I don't see any reason why it shouldn't work perfectly. So once that's wired in, I will start putting the original component values in. I can use this as a guide, and of course the schematic. And then I'll replace all the original resistors that were up here with high voltage type resistors. And then finally put that yellow cap back in place, and then we can try powering this up again and see if we've got in the ballpark of 5,000 to 6,000 volts is what I'm hoping to get. I have the replacement coil wired in temporarily and replaced the resistors and tacked everything back together. If this works, I'll do it more securely. Here we go. Got the high voltage box shield off so I can actually see up into that high voltage tube and see if the filament's glowing. Can't really see anything. We do have high voltage though. Ooh yeah. 4,500 volts. Boy, yeah, I mean, you just cannot see the filament on a high voltage rectifier tube. So, what about the CRT? Let's see, this brightness. Hey! Alright. Signs of life. Let's see now. Pretty height, I believe. Let's see, this is focus. Can't focus it. Horizontal centering. Vertical centering. Doesn't seem quite right there. So vertical centering, I can get it to go off the top, but the bottom stops about here. So that usually indicates there's some issue. It's horizontal hold. That seems to be kind of doing its thing. And it's horizontal size. So with that vertical centering, it could be there's a resistor on either side of that vertical centering control. One of them may be off. Let's try feeding in a signal for the heck of it. No, we're not getting any sound, but now that we have a raster, maybe we can get an image. Since we're hearing some static crashing, it seems like the tuner must be doing something. As I attach these antenna terminals. Let's see. And let's get the converter box going. Right, so I'm feeding a signal from a converter box like I often do. Light again. No, I don't think we're going to have any luck, but certainly a step in the right direction. Now, this focus not working, There's some resistors, high voltage resistors I still haven't replaced. The high voltage is a bit low. Could just be a matter of replacing that 6V6 tube. And it could be that the CRT is kind of worn out. I took a closer look at this focus control, and it's definitely got some strange issues. I disconnected the center connection to eliminate any possibilities of that interfering with anything. All it is it's part of this high voltage bleeder, and there's the center wiper goes to the CRT, which is essentially infinite impedance. And I disconnected that, so that wiper's going to nothing. Well, I measured the resistance to the outside terminals, and it varies as I rotate this control. That's not supposed to happen when there's really nothing connected to it. It should stay constant. I checked on another chassis that's working, and yeah, it stays about 2.5 meg. Doesn't budge as I rotate this control. This one does. Furthermore, the resistance between the center tap and this one outer lug is fixed at about 800K. So internally, something's really gone wonky with that. Could be tin whisker, just something I really haven't encountered much, or at all. Or something arced, and maybe some carbon trace got fried inside there. Okay, what the heck is a tin whisker? Well, some of these controls, they tin plated the body, and over time tin does strange stuff. One of the things it can do is kind of migrate and crystallize and form tendrils of conductive tin, and it can start shorting things out. I don't think that's the case. Most of the stuff I work on is too old. They weren't doing that yet. So these are just either bare steel or maybe they're cadmium plated. And I don't see any evidence of any kind of crystallization or anything. I think it's just some corrosion. But definitely could have been some arcing. Somebody was tinkering with this. There's high voltage involved. If something arced inside, it could have deposited some conducting material where there shouldn't be. Could have damaged the wiper. Who knows? So yet another time to pull a part out of the parts chassis, which is coming in oh so handy. And now when I take this out, we can take a look and see what the issue actually might be. What I do is clip out these two resistors and get at that nut. This whole board can be taken out. I'd rather not, though. I measured the 4 resistors that are down in here, and they all measure okay. So I just as soon not take it all apart. Let's see if I can reproduce those strange results with it out of the set. So here are the outer legs. I'm going to rotate this shaft. That should not change. Which makes me think there must be a short internally between the center wiper and one of the legs. Now this one changes as it should. Pretty much through the whole range of the control. Let's see about the other side. That's the side that's fixed at about 850K. It's not really changing as I'm rotating that control. That's not the way it's supposed to work. So I strongly suspect between the center wiper and this outer lug inside something has gone amiss. It's not too hard to get these guys open. And if you're not too aggressive, it can be resealed. It's entirely possible this can be repaired. And I could have just tried shooting in some cleaner And I would have if I wasn't making a video, because I thought you guys might like to actually see the problem before it gets flushed away, potentially. So how often do you get a chance like this? The problem was between this and this. So there is the carbon deposited in a ring, and the wiper travels along. See, there's kind of some dead spots there. Not too much wear built up. How about on this? I'm not seeing any obvious problems. Looks like it might actually be gold plated. Or maybe it's just brass. If it's brass, why is that tarnished? And I see they have 2 contact points. Sign of a quality control. So, what is the problem? Now, there could have been arcing between, and it's internal to this phenolic base. Oh, and you know what? Check this out. There are some tin whiskers. And real close. Come on, camera focus. On the center element, on the center line here, there are some fuzzy bits of metal. Maybe a little on that too. Now we're looking at about 800K, so we're not going to see a dead short. So one simple thing we can do is brush them away. Let's measure this control again. So now we don't have a wiper or anything. It's just the resistive element. So that center should be infinite. It is on that side. It is on that side. Huh. And the 2 outers should be around 2.5 meg. And it is. Huh. I may have just fixed it. Interesting the way this works. So there's actually 4 contact points. 2 of them run around this ring, and then you're wondering, well, how does it connect up to this? This metal in the middle also has 2 contact points, and that is connected. Well, this whole frame is connected to that center terminal. And so there's a number of places where there could be issues. I was assuming it would just potentially be around these terminals, but no, this entire metal collar is going to that center pin. So if there was any kind of arcing anywhere through this entire phenolic material, that could be an issue. Contact cleaner. Fader, aka potentiometer cleaner for conductive plastic faders and controls. Safe on plastic, flushing action, cleans and lubricates. Dissolves corrosion. This has some acid in it. I realize this is safe on plastic, but I've had it dissolve away. Chemically includes metal to metal connections and contacts. This is for potentiometers. I've had this flush away the deposited carbon from a control until it was basically just gone and the control was completely open. So that's why I don't use it. So loose carbon there, and then I'll clean off the contacts. And it leaves a little bit of a lubrication film on it too. But really, in this case, the problem. I'll clean it off the shaft. It should rotate better. The real problem with this wasn't bad contacts. It sure did appear to be some tin whiskers. Alright, let's put it back together and put it back in the set. Certainly more satisfying than just swapping the control out from a part set. To put it back together, you carefully bend over those little metal tabs. Try to minimize the metal fatigue. Don't need a whole lot of pressure. Kind of alternate the ones you're doing. Almost just do it with my thumbnail. You can do this, if you're lucky, 2, maybe 3 times. Then you're going to start snapping off these tabs. And it's time to try to salvage the body from another control. Or, of course, just replace the control, if you can. Note these have plastic shafts. That's because there's high voltage on these. These are not your everyday potentiometer. That's another reason why I really wanted to save it. Nice. Alright, let's see if it works now. It does make me wonder sometimes, what would they have done back in the day? Spend the time to try to fix a control, in which case you'd be charging the customer for your labor, or do you replace an expensive part, saving the labor, but then they got to pay for the part? Oh yeah, definitely is focusing now. It seems bright though. That's interesting. I'm manipulating the brightness control, so here's one extreme. As I rotate it, it's a little dimmer, and it gets a little brighter, and then it just completely fades out. Weird. So I got almost all the lights turned off on that. Yeah, these sets are dim and they're meant to be watched in a darkened room, but this is a little, little dimmer, I think, than it's supposed to be. Let's see, do I still have a signal attached? Yep. It's weird because the tuner does crunch when I change channels, but just no hint of anything. I continued checking the various circuit points and no smoking guns. Just like on the other two 19A1 chassis I got working recently, a lot of the resistors are 20-30% high. I tested a few of the old caps and they're leaky, but only at their maximum rated voltage. This is leaky at 400 volts, but the set only runs on 250, and if I drop the voltage down to that, it's not really significantly leaky. That was a video coupling cap. Replacing it made no difference. So, a thought occurred to me. I methodically went through and troubleshooted the two other chassis, and I started doing that on this one too. But in the past, I typically would shotgun the caps, turn the set on. Sometimes it'd work, sometimes there'd be some obvious mistakes, fix those, and then generally the set would be working pretty well. So I was thinking, just as a way to kind of compare and contrast, now that the high voltage is back and that focus tin whisker problem has been resolved, I'm going to go through and shotgun this set before I try turning it on again. and let's see what happens. Plus, it's just in the interest of saving time for myself because I'm really backed up with projects, and I want to get this thing done and out of the way. The only reason I'm doing it now is because these chassis are so fresh in my mind that I've got a number of them out right now on the workbench, and I can compare and contrast. So I want to get them all done at the same time. But rather than methodically go through and remove, test, replace one part at a time, fire the set back up and all that, which I highly recommend if you want to learn a little something, you're new to the hobby, or you've got the time. I don't, unfortunately. So that's what I'm going to do. And as like, for example, weak sound, I can see that there's a lot of original caps down in here. And in order to replace them, I got to remove the tuner. So I'm not going to go back and forth and replace and retest and do one cap at a time. It's just not practical. So I'm going to remove this, blow through all that, replace all this stuff. This is the sync deflection circuitry stuff, and this is the sound IF and ratio detector. So when we resume, this should look quite a bit different. I'm going to leave you off now. Hope you've enjoyed this so far, and well, let's see what happens in the next installment.